we are going to solve differential equation using power series. Okay. If you notice, I didn't write what is the type of differential equation. I didn't mention first order, second order, right? Homogeneous, non-homogeneous. I didn't mention anything with constant coefficient, without constant coefficient. I just write it, solve differential equation using power series. Let us think about the power series first. What is the power series? Power series is like that. Am x to the power m equal to 0 to infinity. So if you have it as a series with a small sum, if you put m equal to 0, you have a naught and then a1 x plus a2 x squared plus a3 x to the power 3 plus etc. This is the power series. I think you remember Maclaurin series or Taylor at x equal to 0. Yes, we know this Maclaurin series, any function differentiable and continuous can be written as a power series. This power series using the derivative at x naught equal to 0, this is the n derivative, over factorial n x to the power, n, when n equal to 0 to infinity. I just remind you by one of the example. Yes, if you have f of x equal to e to the x, you can have f at 0, e to the 0 equal to 1, f dash of 0 equal to e to the 0, because the derivative of e to the x is e to the x, right? And etc. All of them are equal to 1, so I'm lucky with the exponential function, because f dash is the same exponential function, and the value at x naught equal to 0 is 1. So if I substitute here, so e to the x can be written as a sum n equal to 0 to infinity for, yes, f dash is 0, f double dash is 0, f at 0, so equal to 1. So 1 over factorial n x to the power n. So I can write it as 1 plus x over factorial 1 plus x squared over factorial 2 plus etc. If you would like to add until x to the power n over factorial n, it is infinite series, right? Also, if you remember the cosine or sine, okay, let's go for the cosine x. If you have a function f of x equal to cosine x, I have f at 0. What is the cosine 0? What's the cosine 0?
1.
1. Yes, good. And if I go for f dash of x, what is the derivative of cosine?
Minus sine.
Minus sine x. So f dash at 0 will be minus sine 0, which will be 0. If I go for f double dash of x will be minus cosine x. So f dash double dash at 0 will be minus cosine 0, which will be minus 1. If I carry on and then substitute in the Maclaurin series, the cosine x will be 1 minus x squared over factorial 2 plus x to the power 4 factorial 4 minus x to the power 6 over factorial, because it is even function, so you have only the power, even power, right? Also, you can write it as a big sum from m equal to 0 to infinity, and you have x to the power 2m over 2m factorial. Okay, this is a cosine x. There is a very nice example, which is 1 over 1 minus x. It is 1 plus x squared plus x cubed plus etc. You can have it as a big sum, x to the power m equal to 0 to infinity. You don't have a coefficient like this one. The coefficient is 1. Okay, this is a power series, and we remind you, since any function can be written as a power series, right? So the solution will be a function of x. So it is fair enough to use the power series to solve a differential equation, right? Let's have an example for this one. Use the power series to solve y dash minus y equal to 0. But this is a first order differential equation. We know this is first order differential equation. Y dash minus y equal to 0. First order differential equation. Separable? Yes. And it is separable. You can solve it without the power series? Yes. How I can solve it? I just remind you. This is dy by dx equal to y. You separate y with y and having dx here, and you just integrate. You have ln y. Do you remember this question we solved it? And you have x plus c. So y equal to x plus c, which is, we can call this one c1, so c e to the x. So we solved this one before, right? But it is compulsory now to use a power series. This is without a power series, okay? Let's do it by the power series. So I let y equal to the sum of, you can call it c m x to the power m or n. It's up to you. If you like to call it n, that's okay. I'll go with n, x to the power n equal to 0 to infinity. Once y equal to this one, I would like to substitute in the differential equation. So I have to find y dash. Now, how to find the y dash? Cn is a constant. How to differentiate x to the power n? I get the power down and subtracting 1. So I get y dash, and I have y. Now I substitute in the differential equation. All of these steps, we will do it in every question, right? Okay. Now I will substitute in the next page just to be easy for me. Now I just remind you, I have y equal to the sum Cn x to the n equal to 0 to infinity, and y dash equal to the sum Cn n x to the n minus 1, and n start from 1. Why start from 1? Because if it start from 0, you have 1 over x, so it will not be power series with a positive power, right? So we'll start from infinity, and y double dash will start from n equal to 2. Now when I substitute, I have y dash minus y equal to 0. So I can substitute in this one. What I have? Yes, I have from n equal to 1 to infinity, Cn n x to the n minus 1 minus sum n equal to 0 to infinity Cn x to the n equal to 0. Now, as I told you in math 1, you have to catch the power, and the counter will start from the same counter, okay? But this is easy one, because if you replace the big sum, okay, with a smaller sum, so when n equal to 1, what do you have? Yes, you have C1 x to the power what? 1 minus 1 plus C2, and you have 2, catch it, x to the power 2 minus 1 plus, if n equal to 3, you have C3, and you have 3 here, x to the 3 minus 1 plus, okay, minus what? Yes, I'll have to open bracket because I have a negative. N equal to 0, you have C naught x to the power 0 plus n equal to 1, C1 x to the 1 plus C2 x to the power 2 plus C3 x to the power 3 plus etc. All of these one equal to what? Equal to 0. Now x, this is x to the power 0, so it is 1, and also this is 1. Now I can catch the same power, right? So I have C1 minus C naught, okay, plus, let's go for x to the power 1. This is to the power 1, so I have x to the power him. So I'll take x as a common factor. So what do you have? You have 2 C2 minus, be careful with this minus, right? I will write it. Okay, I will write it in front of the bracket just to make it easy for you to be very careful with this. Okay, 2C2 minus C1, right? Next. Okay. So I'll get the constant, I'll get the coefficient of x and take x as a common factor. I will take x squared as a common factor. What is the coefficient of x squared? Yes, I have x squared here. The coefficient 3c3 minus, because I have a minus here. What is the coefficient of x squared? Is c2. Okay, plus I'll go for x cube. I will write it here. Okay, what is the coefficient of x cube? If you can add one here, you have c4, and you have 4 x to the power 4 minus 1, right? So what is the coefficient of x to the power 3? Is 4c4, 4c4. And what do you have x to the power 3 here? c3. So minus, because this is a minus outside the bracket, minus c3. And you can carry on, right? All of these one are equal to what? Equal to 0. So comparing the coefficient, what do you have? You have that there is no constant here, so this will implies to what? Yes, implies to C1 minus C0 will equal to 0. This is implies that C1 equal to C0. Okay. Now the second one, 2. This one, the coefficient of x is also equal to 0 because I don't have any x in the other side. So I have 2C1 minus, 2C2 minus C1. C2 minus C1 equal to 0. So this one will implies to C2 will equal to half C1. C1 is equal to C naught, so it is C naught over 2. So I have C2 in terms of C naught, right? And I can take this one also, the power of the coefficient of x cubed. So I have 4 C4 minus C3 equal to 0. So C4 will equal to C3 over 4. C3, okay, I forget this one. The power 3 here is C3. So, and the power of 3 here is 4C4. Yes. Okay. So I can get the coefficient like this, right? Catch it? Okay. This is exactly what I have done. Look at this one. I substitute, I get this one, and I get this one, and get this one. So I get A1 equal to A naught. Exactly. He call it A, I call it C. Says no, C1 equal to C naught. He has here A1 equal to A naught. Once I get A1 equal to A naught, A2 is equal A naught over 2. So this 2 I can make it as factorial 2, right? So this one I can call it factorial 2. And this one will be factorial 3. So my solution will be y equal to, yes, C naught plus C naught over factorial 2 x plus C naught over factorial 3 x squared plus C naught over factorial 4 x 3 plus etc. Now I can take C naught as a common factor. So what's left? 1 plus x over factorial 2. Sorry. Yeah, this is factorial 1. Sorry. This is factorial 2. This is factorial 3. So I can write this one as x squared over factorial 2, x3 plus etc. Do you remember this one? Yes, I just mentioned it to you before I start solving this one. I told you that Maclaurin series for the exponential function is this is the one, right? So my solution will be y equal to C naught e to the x. This is the same solution as I have done using the separable method, right? This is the solution, right? This is the solution I've got when I was solving this differential equation using the separable method, right? So using the power series, you will catch up the same solution you got, but in terms of power series, right? Catch it? Let's go for another example. Now I'm asking you solve one plus x y dash equal to y. Using the power series. Can you remind me this one plus x y dash equal to y? This is also separable, right? 1 plus x dy by dx equal to y. So I can separate this one, so I can get y with dy, and I get dx with the x. Now I can integrate. This is what I used to solve when I got the first order differential equation. So this is ln y equal to ln x1 plus x plus, I prefer to make it c1, and then I'll take the e for both sides. So if you get e for this 2, what do you have? Yes, you have y equal to 1 plus x e to the c1. This is, I can call it c, so c times 1 plus x. This is the solution before I know the power series method. But if it is compulsory, yes, you have to go to the power series because the question asking you to use the power series. Can you start with me, please? Yes. How I can solve this one using the power series? First, in every question using the power series, I will let my dependent variable, which is y, in this case, equal to, yes, a sum of, you can call it c, you can call it a, it doesn't matter. C, you can call it m or n, it doesn't matter. I will call it n. X to the power n equal to 0 to infinity. What is the next step? Yes, this is the derivative, the differential equation, so I have to get the differentiation. I have only first order, so I need y dash. Y dash, this is a big sum. Cn, I get the power of x down and subtracting 1 from the power. But the counter here will not start from 0, because if it starts from 0, it will be x to the minus 1. Okay? So I have to start from the counter n equal to 1. Okay. Now, substitute in the differential equation, right? So substitute in the differential equation. 1 plus x times y dash equal to y. Now I'm just going to substitute 1 plus x sum n equal to 1 to infinity Cn, and I have n x to the n minus 1 equal to the sum Cn x to the n equal to 0 to infinity. I can move this one to the other side, right? So what I have, okay, or before I move this one, I can multiply this one inside. So how many parts I have? I have 2 parts. 1 times this one and x times this one. So I have 1 times this one. I will have sum n equal to 1 to infinity for Cn. Please write with me. Cn n x to the n minus 1. Good. X times this one. Yes, it will be sum n equal to 1 to infinity Cn n. When you multiply x by x to the n minus 1, you have x to the power what? X to the power what? X times x to the power n minus 1. You add the power. N. Excellent. Equal to sum n equal to 0 to infinity for Cn x to z. Now, I will move this one to the other side. Just remind me what I have. I have a sum n equal to 1 to infinity Cn n x to the n minus 1. Okay. And Cn n x to the n Cn n x to the n min n equal to 1 infinity. And I will move this one to the other side, so I will have minus sum n equal to 0 to infinity, Cn x to the n. Yes, equal to 0. Because I move everything to the other side. Now, I have no problem with this one. I have no problem with this one. I have a problem with this one. Why? Because I would like to make this power similar to x to the n. So I will replace here, I will replace n minus 1 by a new counter. I call it k. So if you take k equal to n minus 1, so when n equal to 1, k will equal to what?
0.
0. Excellent. Okay. So the counter now will counting from k equal to 0. This is why I'm asking you to write with me to infinity for instead of n will equal to what? K plus 1 because I take n minus 1 equal to k. So I replace n by k plus 1, right? This substitution for the counter, very important to make all of them as x to the power k, right? In the second one, I have no problem, right? So I take n equal to what? Equal to k, right? Because I have already x to the power n, so I can make it x to the power k plus sum. I replace n by k in this one, k equal to 1 to infinity, ck k x to the power k. Fine. Now, with this one, also, I have no problem. I can take n equal to k also, right? Remember, when n equal to 1, k equal to 1, right? But in this case, when n equal to 0, k equal to 0, right? So, plus, minus sum from k equal to 0 to infinity for c k x to the power k, all of these things equal to what? Equal to 0. Now I have all of them having the power k, but the problem, the counter here start from 0, but in this one, they start from k equal to 1. So I have to get one term from this one and one term from this one, and to let the counter start from k equal to 1. Okay. Let's take so I will take one term from this one. So when you take one term from this one, you put k equal to 0, so you have c1. Okay, c1. You put k equal to 0, so you have 0 plus 1 x to the power 0 plus your counter will start from k equal to 1 to infinity for ck plus 1 k plus 1 to the power x to the power k. Now I would like to have also 1 from this one, right? From this one I will take 1, so I will have minus, when you put k equal to 0, so you have c naught, okay, x to the power 0, and you left over with minus sum from k equal to 1 to infinity for ck x to the power k. Now I'm ready, all of them starting from the counter k equal to what? Equal to 1, okay? Catch it? X to the power 0 is 1, x to the power 0 here is 1, okay? Now can we write it? C1 times 1 is C1 minus C naught. So this one with this one. So I have C1 minus C1 minus C naught. And let us write the sum, the big sum. The first big sum here, ck plus 1, k plus 1 plus ck plus 1, k plus 1, x to the power k, okay, from k equal to 1 to infinity. And the second one, which I didn't change because it starts from the 1 already, ck x to the power k. All the counters start from 1. And the last sum I change it and I take 1 from this. This is a 1. ck x to the k. Again, yes, ck x to the k from k equal to 1 to infinity. All of these things equal to what? Equal to 0. I will write the 0 on this side. Now, the coefficient, comparing the coefficient, so this one, there is no constant on this side, right? So, by comparing the coefficient of x to the power k, right, in both sides. You are lucky because you don't have x here, so all the coefficient will be 0, right? Now, the constant value 0 equal to C1 minus C naught. This is the first thing I got. So C1 will equal to C naught. Okay. Now, let's go for the coefficient x to the power k. This is the coefficient of x to the power 0, right? What about x to the power k? X to the power k. I have 0 in this side because I don't have anything with x, right? What is x to the power k? From the first one, yes, ck plus 1, k plus 1 plus ck times k minus ck, right? All of this one equal to 0. I can take ck as a common factor here, so you have k minus 1, and I have k plus 1 here, and I write it ck plus 1 like this, just to have the coefficient equal to 0. Now I can move this one to the other side, so I will have ck plus 1, okay, equal to minus k minus 1 ck. And here you have k plus 1. So I move this in the other side, so I have, okay. So if you would like to write it nicely, you just keep this one, k plus 1 ck plus 1 equal to minus k minus 1 ck. I'm looking for ck plus 1, so ck plus 1 will equal to this minus. I can take it inside, so it will be 1 plus k over k plus 1. Is it correct? So this will be minus. This will be minus k, and this is k plus 1 ck. What I'm going to do with this one? Yes, if you put k equal to 1, you will have C2 equal to in terms of C1, and you know C1 in terms of C naught. So all of your series will be in terms of C naught. Catch it? guys?
Yes, doctor.
Yes, doctor.
So the solution y equal to the sum of Cn x to the power n equal to 0 to infinity, C1 equal to what? C naught. Okay, this is the first one I got. And I got Ck plus 1, Ck plus 1 equal to 1 minus k over k plus 1 Ck. Okay, from this one you catch up. When you k equal to 1, you have C2 equal to what? What a k equal to 1? If k equal to 1, yes, excellent. So C2 equal to 0 over 2 C1. So this one will equal to what? 0. Put k equal to 2. So what do you have? C3 equal to what? 1 minus 2 over 3, right? C what? C2. So you have minus 1 over 3 C2, C3. I know this is C3, right? Now, if you would like to have C4, let's go for C4. Put k equal to what? 3. So what do you have? C4 equal to what? Yes, 1 minus 4 over 4 plus 1. C what? C3, right?
Yes.
So C3 equal to what? Minus 1 over 3 C2, right?
Yes.
Okay. So you can write it minus 3 over 5, and C3 is minus 1 over 3 C2. This is C4. So all of this coefficient will be in terms of C2 and C naught, right? Why this one? All of them will be in terms of C naught only, okay? Because I know C2 equal to what here? C2 equal to what? 0.
0.
So C4 will equal to 0. All the even coefficient with suffix even coefficient will be 0, right? So this is C2, C4. Everything in terms of C2 or C4 will be 0. Everything in terms of C0 will not be 0. Catch it? Catch it? This is how to solve the first order any differential equation using the power series. Okay. Now, if you would like to try another one, we can try another one. Let's go for a second order differential equation. Okay. Maybe this is the first order and we can solve it. Let's choose one, please, for me to solve it. I'll solve the one down here, right? Can you choose one for me to solve it for you?
12.
Oh, sorry?
12.
12, okay. Solve 1 minus x squared y double dash minus 2x y dash plus 2y equal to 0 using power series. Even without the power series, you don't know until now how to solve this one without the power series, right? Because the second order differential equation with non-constant coefficient. Okay. Okay. This is, just remind you, this is a second order, linear, homogeneous. Yes, homogeneous, because you don't have a function of x here.
دكتور ممكن بس الشاشة.
Yes, sure. Homogeneous with non-constant coefficient. Non-constant coefficient. Okay. I don't care if you know this differential equation, second order linear, homogeneous with non-constant coefficient or not. I would like you to solve it using the power series. So what you are going to do, you just let y equal to the sum of Cn, please do it with me, x to the power n equal to 0 to infinity. This is the solution. You would like to substitute in the differential equation. In the differential equation, you have second derivative and first derivative. And of course, you have y. So you need to differentiate this one. Sum Cn, you get the power of x down, and you're subtracting 1. You cannot start from 0, so you start from make this one x to the power 0 to infinity. You need y double dash. So you need y double dash equal to sum Cn. Yes, I have already from the first derivative, I have n. I differentiate again, so I'll get the new power here down, x to the n minus 2. All of you have done this one? Yes, but the counter will start from n equal to what? 2.
2.
Please write down all of these things. Now let's go to the differential equation, okay, and substitute. I'm waiting you to write it down. You know how to differentiate this one? Okay. Now let's go and substitute in the differential equation. I have 1 minus x squared times what? Y double dash. What is y double dash? As I remember, n2 to infinity. I have Cn. I differentiate twice, so I have n times n minus 1, x to the power n minus 2. And then I have minus 2x minus 2x sum. I differentiate once, so I have Cn, and I have n x to the n minus 1, and the counter start from n equal to 1 to infinity, plus 2y plus 2y. What's y? It is Cn x to the power n, and start from 0 to infinity. All of this one will equal to what? Equal to 0. Now, as we mentioned before, you have to make all the power x to the power m or k or whatever, right? You just make it one piece. Fine. So let's go for this one, okay? And multiplied inside. So multiply by 1 and then multiply by x squared. So I have two sum. 1 multiplied by 1, which is the same as this one. I have the sum from n equal to 2 to infinity, Cn n minus 1, x to the n minus 2. This is a multiplied by 1. Let's multiply by x squared. So when you multiply by x squared, the counter is still as it is, right? But when you have x squared inside, the power will be changed from x to the n minus 2 into x to the n, right? If you don't like to do it, you just make it -2 plus 2. Okay, so you cancel out this one. So it will be x to the power n. So this is will be x to the power n. Fine. This is the first sum. The second sum, also I will take this x inside this one, right? So what I have minus 2 sum n from 1 to infinity Cn n. When I take x inside, it will be x to the power what? N minus 1 plus 1. So all of this one will be n, right? Plus the green one doesn't change because I have also 2 outside, and this is, you keep it as it is. All of this one equal to 0. Now we have to replace every power different from n, and up to this one will change the counter. Let's go for this one. Yes, in this one you should have what? N minus 2 equal to k, right?
Yes.
Okay, so in this one you put n minus 2 equal to k. Okay, so when you put n equal to k, n minus 2 equal to k, n minus 2 equal to k. So when n equal to 2, k equal to what? 0, right? And n will equal to k plus 2. Can you replace each n by k plus 2 and you start your counter from k equal to 0 and write this one? Okay. This one, no need to change anything because you need only just to replace in this one, you replace n equal to what? K. Also in this one, you replace n by k. Also in this one, you replace n equal to k. Right? Because the power is n, so I'll keep it. And the counter will stay as it is. Can you please remind me how to write the first one?
It will be
Sum from k equal to 0 to
till
infinity,
infinity
ck
plus 2.
plus 2, and here you have k plus 2 times k plus 2 minus 1, right? So it will be k
Yes.
plus x to the power k. Yes, I finished this one. The rest will be stay as it is, minus sum n just by k. So k equal to 2 to infinity ck k k minus 1 and x to the power k. Let's go for the blue one. The blue one is minus 2 sum. I just replace n by k. K start from 1 also to infinity ck, and then k x to the power k. And the green one plus 2 sum, you replace n by k, so you have k from 0 to infinity for ck x to the power k. All of this one equal to 0. Now let's go and look at this one. The counter here start from 0. The counter here start from 2. The counter here start from 1. Start from 0. So we have to make the whole counter start from what? Yes, from the
2.
bigger one. Yes, from the bigger one. So we have to get 2 terms from this one, 2 terms from this one, 1 term from this one, right? So in this case, I will have the 2 terms. The first term, I have it by k equal to 0, plus I substitute k by 1, so I get the 2 terms, and I can start from k equal to 2. In this one, I put k equal to 1, I will have the term and I start the big sum from k equal to 2. Okay, for this one, I put k equal to 0, k equal to 1 to have the second term, and plus the big sum start from k equal to 2, right? Catch it? So what I'm going to do, I'm just erasing this one. And you let me know how to expand this big sum. So from the first one, you take two terms. The first term when you k equal to 0. When you k equal to 0, what do you have? You have C2, right?
Yes.
C2. What is the coefficient? K equal to 0, so you have 2 times 1, right?
Yes, 2.
So you have 2, right? Okay. So you have 2. What do you have? X to the power what? When you put k equal to 0, x to the power 0 is 1, right?
Yes.
So I have C2 and I have 2. X to the power 0 is 0. Now I'll take the second term. The second term k equal to 1. When you put k equal to 1, you have C what? C3, right?
3.
And the coefficient will be 1 plus 2, 3. 1 plus 1, 2. So you have 3 times 2. So you have what?
6.
6. X to the power what?
1. X.
1. X. X to the power what? 1. Now I can write the big sum start from k equal to what? 2,
2.
right? And I write it as it is. So it will be C k plus when it start from 2, okay, and I will write the coefficient x to the power k. I finish with the black one. Let's go. The red one, I'm not going to change anything because it starts from the counter. The big counter, I keep it as it is. So I have minus sum k equal to 2 to infinity ck k times k plus 1 x to the power k. Now I'll go to the blue one. The blue one, how many terms I need from the blue one? Only one term to start from the counter k equal to 2. So I have minus 2. When you put k equal to 1, what do you have? You have C1, right?
Yes.
X to the power what? Yes, x to the
1.
power 1. Good. Now, the blue one can start from what? From k equal to 2 to infinity ck k x to the power k. Now I finish the blue one. Let's go for the red one, the green one. The green one, I need two terms, right? The first term when
Yes.
k equal to 0. So what do you have when you put k equal to 0? You have what? Plus 2. K equal to 0, you have what? C naught, right? Plus, when you put k equal to 1, you have what? C1 times x, right? Now you get two terms, so you can start your counter from k equal to what? To infinity. Ck x to the power k. All of these equal the other side 0. Now I can compare the
دكتور
coefficient. Yes.
مش لازم تكون يعني 2C2 plus 2C1
Yes, yes,
X.
all right. Yes, yes, you're all right. I missed this too, right? I missed the two outside the sum. Thank you very much. Very good. Yeah, I missed this too. I missed this too. This is 2 here, right? So what is the 2 here, right? Here
Yes.
and here, right?
Yes.
Good. Now, let's go for the last step. You just compare the coefficient. Compare the coefficient in both sides. So what do you have? What is the constant? The constant is only 2C2, right? Do you have any other value? Guys, do you have any constant here? Yes. 2C,
2Z.
C0, right?
Yes.
So
yes, only this.
x to the power 0, which is the constant values. What do you have? You have C2 times 2 plus 2C0, right? So this one gives you what? 2C2. I can cancel out this one. All of this one will equal to 0. Okay. Don't know what happened with this one. All of this one, C0 equal to 0. So this gives you what? I can cancel out this one. So C2 equal to what? Minus C0. This is the first one. What about the power of x to the power 1? Where is x to the power 1? Here it is, right?
Yes.
And this one, right?
Yes.
So I have C3 times 6. This is a coefficient. I'm not taking x. Plus 2C1 equal to 0 because I have nothing in the other side. Okay, so I can cancel out this one. So I have 3 over here. So 3C3 equal to minus C1, right? So C3 will equal to minus C1 over 3. Be careful. C2 in terms of C0, C3 in terms of C1. I need two constants because my differential equation is a second order differential equation. So I know I will have only two constants, right? Now let's compare x to the power 2. Where is x to the power 2? I don't have it inside. I have it. I don't have it outside. I have it inside the big sum, right? Catch it? So
yes.
when k equal to 2, k equal what? To 2. What do you have in the first sum? C what? C4 times 4, because k equal to 2, times 3 x squared. And in the other sum, I will just give it in the same color. Okay, I will put it in the same color. In the black sum, when k equal to 2, what do you have? Hello? K equal to 2 in the black sum? C4. And when you have k equal to 2, you have 2 plus 2 and 2 plus 1, 3 times, so you have 6. Okay? In the orange one, this one, minus, when you put k equal to 2, what do you have? You have C2 and you have minus 2 here and 2 plus 1, so you have also 6.
Doctor,
Okay.
in the black brackets, it will be 2 plus 2 multiplied by 3, so for 12.
Oh, 12, sorry. Thank you. So you have 12. Okay. Now, k to the power 2 in the orange one minus C2, here is 2 and 2 plus 1, so you have 6. And in the blue one, you have, when k equal to 2, you have 2 and you have minus 2 and you have 2 inside, 2C2. So you end up with what? Let's write it down. You have 2 outside and you have 2C2. And in the green one, what do you have in the green one? You have 2 outside. Be careful. You have 2 the outside, and you have k equal to 2, so you have C2. All of these one equal to what? Equal to 0. Now, I will replace C2 by what? By minus C naught, right? Catch it? But before I do this one, I have minus 4C2 plus C2 minus 6C2, right? So what do you have? How many C2 you have? Minus 6
3.
minus 4 minus 10 minus 10 plus 2, 8, right?
Oh, yes.
So you have 8 C2 minus, and you have 12 C4, right? Equal to 0. So C4 will equal to what? When you divide it by 4, you have 2 and you have 3. So your C4 will equal to what? Yes, will equal to C2 over 3, right? C2 over 3. And you know C2 equal to what?
Minus C naught.
Excellent. Okay. C2 equal to what? C4 equal to C2 over 3.
Doctor,
So
it's 2C2 over 3.
yes, 2 over 3. So it will be minus C naught. C3 is what? C2, sorry. C2. C2 is minus C naught. So you have minus C naught over what? Over 3, right?
Yes.
This is the C4. All the coefficient will be in terms of C naught and C1, right? So my solution is what? My solution is y equal to the sum of Cn x to the power n equal to 0 to infinity. And I have what? The first one, C2 equal to C naught. C2 equal to minus C naught. And C3 equal to minus C1 over 3. And C3 equal to minus C1 over 3. And C4 equal to minus C naught over 3. Is it correct? Yes.
Yes.
And you can carry on, right? Okay. But in general, no need for just having x squared, and I can go for x to the power k, and k start from 2, right? So I can take the whole coefficient. I can get a relation between ck plus 1 and ck, right? But to make it easy for you, you can follow the same steps. Now I finish my turn, and it comes to your turn. Please try to do this one after you show me what you have done so far.